Hello girls, how are you today? Hope you're fine. Today we're gonna continue our math classes with lesson 9.9, adding mixed numbers. Before we start operating on mixed numbers, we have to understand what is a mixed number. Let's check our examples here. First example is 2 and 4 over 8. Second example is 3 and a half, 1 over 2. Our third example is 1 and 8 over 10. You can notice that mixed number is made up out of two parts. The first part is a whole, a full number, a whole digit. The second part is a fraction, parts of a whole. If you want to represent this mixed number as a model, we can see that we have two wholes, 1, 2. 1 plus 1 plus the part of the fraction, which is here 4 over 8. This means each whole of these means that we have 8 over 8 pieces. 8 out of 8 means that we have filled this whole completely. We used the 8 parts of each of these two wholes. That's the meaning of the fraction 8 over 8 or 6 over 6 or 10 over 10 or 100 over 100. This is the meaning of that. But with the third box or with the third whole, we only filled 4 over 8 out of the 8. We didn't fill the whole parts of the whole. We didn't complete filling the parts out of the 8. We only filled 4 parts out of 8 parts. So if we go to example number B, it shows that we have 3 and a half. This 3 means that we have 3 boxes or 3 holes. Each hole is divided into 2 parts. How did we know that it is divided into 2 parts? By checking our denominator. The denominator represents the number of the parts in each whole. So these 3 means 1 plus 1 plus 1 plus half. Since we have 3 holes, means that we have to complete 3 boxes. The first one, we used the 2 parts. That means 2 over 2 plus the second one, we used 3 parts too. Sorry, 2 parts, not 3. Sorry for that. It means 2 over 2. And for the third part, for the third box, we used 2 over 2 parts again, which means 1 or a whole, or 2 over 2 completely. Okay? But with the fourth box, we only used 1 part out of 2 parts, girls. So plus 1 over 2. This 1 plus 1 plus 1 represents what? The 3, this 3. Now, if we check our number here, we have 2 over 2, it's a fraction. We have another 2 over 2, it's a fraction, and another 2 over 2, and these 3 fractions, each one of them equals 1. If we are going to combine 2 over 2 3 times plus 1 over 2, it will give us again the same mixed number, 3 and a half, and which we can see it in the model here. One last example is 1 and 8 over 10. 1 here represents what if we need to break it down into a fraction? What's our denominator? It's 10. So the first whole is divided into 10 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pieces. The 1 here means that we fill the whole 10 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is for the whole part. Okay. And what about the fraction part? 8 over 10. How many parts out of a whole divided into 10 equal pieces we used. Here is the second whole. It was divided into 10 pieces according to our denominator, and we used only, or we filled, or we shaded only 8 out of the 10, like this. 1, 2, 3, 4, 5, 6, 7, 8. This is 8 over 10. So if you want to represent this one in a form of a fraction, it's going to be what? 10 out of 10 plus 8 out of 10. If we add them to write them in form of a full fraction, not a mixed number, it's going to look like this: 18 over 10. Or if we decompose it, as we learned earlier, we will write it as 10 over 10 equals 1 plus 8 over 10, and it will go back again into 1 and 8 over 10. Now, let's take some examples about mixed numbers, and we have to list them or to categorize them into whole part and fraction part, like 3 and 6 over 8. Now we have 10 and 2 over 5. This is B. C, we have 1 and 11 over 20. And we have 9 and 7 over 12. Okay, we have whole part and fraction part. In A, what was the whole part? 3. What was the fraction part? 6 over 8. And let's write the denominator. That will help us to check the number of the parts in the whole. Denominator. What was the denominator in A? It was 8. Now for B, what was the whole part? 10. What was the fractional part? 2 over 5. What was the denominator? 5. For C, the whole part was 1, the fraction part was 11 over 20, and the denominator was 20. For D, the whole was 9, the fraction was 7 over 12, and the denominator was 12. Now we can start adding. If you noticed earlier, we can only add any fraction if the denominators are alike. We can only add or subtract even, or subtract fraction if they have common denominator. Okay, let's find the sum. Next, numbers. Let's try the first method based on our earlier information. If we have 1 and 2 over 3 plus 3 and 2 over 3 Now let's check before do any operations for these two mixed numbers. We have 1 and 2 over 3 plus 3 and 2 over 3. Let's put a box around our whole part. The whole part in the first number is going to be 1. The whole part in the second number is 3. The fraction part is 2 over 3 here and 2 over 3 here, which means that they have the same denominator, so we can add easily. How we are going to add? Now we're gonna add the whole numbers together and add the fraction part together. Since they have the same denominator, it won't make any issue. So here, what does it equal? We will write it this way: 1 plus 3 and 2 over 3 plus 2 over 3. It will equal what here? This is the whole part and this is the fraction part. It's going to be 4, and 2 plus 2 equals what? 4 over 3. We don't change. Now the whole part in our mixed number after we add was 4, and the result of adding the fraction part was 4 over 3. So we're gonna read it as 4 and 4 over 3. It was super easy. Let's take another example. Like if we have 6 and 3 over 4 plus, or over 14, let's make it a little bit bigger, plus 2 and 5 over 14. We're gonna use the same way that we used earlier by adding our wholes. The whole number here is 6 and the whole number in the second is 2. So we're gonna add the whole part together and add the fraction part together like this: 6 plus 2 and 3 plus 5. Why we were able to add the 3 and the 5 easily? Because they have the same denominator, which is what here? It is 14. 3 plus 5 over 14. So the answer will become 8 and, but we don't need to write it here, 8 over 14. By accident, the number becomes the same. It was accidentally, girls. Let's take a third example. Like if we have 29 and 1 over 5 plus 22 and 3 over 5. What was our whole parts here? 29 is the whole and 22 is the second whole. The fraction part was 1 over 5 and 3 over 5. We're gonna add the fraction part together and the whole part together. This is the whole part and this is the fraction part. For the whole part, it's going to be 29 plus 22 and 1 over 5, 1 plus the 3. Both of them, the 1 and the 3, are over 5 because we have the same denominator here. Okay? So the result of the addition here will become what? 2 plus 9 equals 11, which means 51 and 4 over 5. Okay, this is the first way. The second way that we have to add mixed number is to convert mixed number into a proper fraction. How? Let's take the same examples that we took and compare the result. The first example that we took was 2 over 3. 1 and 2 over 3 plus 3 and 2 over 3. If I am going to switch or convert each of these mixed number into a proper fraction, I'm going to use this way. 3 multiplied by 1 plus 2. This way. By tracing the arrows. And here, 3 multiplied by 3 plus the 2 here. Yeah. So 3 times 1 equals what? 3. The result is here. Equals 3. Then this 3, I have to add it to the 2 that we have it here. This 3, the result of the multiplying, I need to add it to the 2 on the top of the fraction or to our denominator. It will become what? 3 plus 2 equals 5 over what? Are we allowed to change our denominator? No. So I'm going to use the same denominator. Plus 3 times 3 equals 9. 9 plus 2 equals 11 over what? The same denominator, which is 3. Okay, how come we're going to say this is true? I'm going to convince you. Let's decompose the 1 and 2 over 3. Like this. 1 on a side and 2 over 3. We explained that earlier, that this one is equal to what? 3 over 3. Why 3 over 3? Because it is a whole made up of 3 parts according to our denominator, plus 2 over 3. We have the same denominator with 2 fractions. Can we add them? Yes, we can. 3 plus 2 equals 5 over 3. Isn't this 5 over 3 is the same result of multiplying 3 times 1 plus 2? Yes, they're the same. Let's try to do the 3 and 2 over 3 by decomposing it. 3 and 2 over 3. This 3 represents 3 over 3 plus 3 over 3 plus another 3 over 3 plus the 2 over 3. 3 over 3 equals 6 plus another 3 equals 9 plus 2 equals what? 11 over the same denominator. Isn't this 11 over 3 equal to the 11 over 3 that we found earlier? They're the same. So can we add now? Yes, we can. 5 over 3 plus 11 over 3 equals what? 16 over 3.